So, looking at the chat, I see that everyone has joined successfully. So maybe let's give a minute for everyone to upload to connect to our meeting, and we will start. Okay. So welcome everyone on our today's meetup. Today we will have 3 presentations. The topic we would like to cover today is observability. That's one of the very important topics for modern solutions. And today we will have 3 presentations. So the first presenter will be Piotr Jachowicz, who will cover the topic Open Telemetry. The next one will be Daniel Falou, who will cover CAE, so it's Common Engineering Platform. So it will be infrastructure observability. And the next one, third topic, will be covered by Bartłomiej Tyrpa. It will be multi-cluster monitoring based on one of our live products. So let me introduce the first presentation. And our presenter, Piotr Jachowicz. So Piotr Jachowicz is one of our lead developers at Motorola Solutions at Krakow. He is working for many years on different complicated large systems, and the current project is related to a distributed system in Azure Cloud, which has open telemetry introduced in this project. So the topic will be open telemetry saves you time, and Piotr will cover it. After the presentation, there will be 5 to 10 minutes to ask your questions and to answer them. Please feel free to put your questions in the chat, and I will read them after the presentation. So, Piotr, now it's your time.
Thank you. Hello, good evening, everyone. Today we'll cover OpenTelemetry and telemetry itself, and we'll talk about the problem. So if OpenTelemetry is an answer, what is the question? Meaning, what is the problem we are trying to solve using OpenTelemetry? On this diagram here, you can see our command central deployment. It is a cloud deployment. Every rectangle is a separate service deployed in the Azure cloud, and the arrows describe connections between the dependencies between them. It looks complicated, but believe me, it is not the most complicated deployment I saw. It is not the biggest one. It is a medium to small size deployment, and pretty much all deployments look like that. And the net is dense because services provide some API, and whoever likes to use this API, whoever likes to use this functionality, just use these services. So the service does not decide who will use it. It just provides functionality, and everybody is free to use it under some circumstances, of course. So if we have a traditional approach based on logs, let us imagine something happens. It is usually the case if you in your life of developer that some service stop responding, start responding with the wrong code, start delay response, and so on. You like to know what's going on, so you just involve the team who develops this service. The team looks into their code, asks you for when it happened, what is the correlation ID, or some details just to track the certain point in logs, or they see this is another service whose response was delayed. So we are involving another team. The team starts grabbing into their logs, and so on and so on. Services are written in different technologies. In Motorola, in Command Central, you have 4 technologies. It is Node.js, C#, Java, and Python. Are developed by independent teams, so the log level are different. How information in logs are different. It is very complicated task, and we end up in the situation while we scrapping about some problems we have started involving more and more people and more time. And solution to this problem, how can we combine, can we have a common view for all our deployment, is tracing. If you ever have a opportunity to work with profiling, profiling is just a view of what method is invoked, when, how time did it take, and how it ended. Tracing is similar concept, but on the scale of the whole cloud deployment. If we are talking about tracing, we need first to touch two terms, traces and spans. So trace is collection of spans denoting the same operation. The operation can be user clicks submit. When user clicks submit, several actions start. And span is unit of work. Span is one specific action with a trace. Span have duration, of course. Span has some name, and it is usually provided automatically by the framework we use. However, developers can enrich spans with the information they like. So we can add custom attributes to span, like number of request units from the database. We can also add events and then use those events to retrieve some information from span. Sorry, the event can be that the cache was hit or the cache was missed. And this information can allow us further in looking into the whole processing of the trace. How can we use tracing? First obvious usage is local optimization. Let us look at this example. We have an operation which takes 164 milliseconds, and under this operation there are several operations involved, including create log, which took 54 milliseconds. If you like to optimize our application and we don't like to do it in a random way, we should focus on this create log because it is the longest, most critical operation under this span. If we can optimize other items, of course, but if we shorten this 164 milliseconds by 1 millisecond, it is not a great achievement, but you can focus on the spans which really matter in our flow. So this is the first usage, local optimization. But we have more. We have global optimization. I told you already that span tracing is profiling on the deployment, cloud deployment level. So if we are developers of some service, we create API for this service, and we usually have some usage in mind. But our users are creative, and they rarely use our service in the way how we developed it. If we have tracing, you can discover how our service is used and optimize it. For instance, if we have a very heavy operation, which takes a long time and reveals some result, which does not change very often, and we discover that our users are calling this operation again and again and again, it is obviously a waste of resources, we could cache it and return them from cache. And the necessity to cache it stems from looking into traces. Also, if we have traces across the deployment, we can see how we use other systems and the situation reoccurs. Our system's code usually has hundreds thousands of lines, and it is very hard to tell from the code if we are for instance, overusing some other system, if we can cache the results, if we make a redundant call, it is visible on traces. So we can optimize our system as well. Third usage, and it is one of the favorite questions asked for developers. Why your request took 2.7 seconds? Yesterday, there was a very long request. Usually it takes 500 milliseconds, but yesterday it was 2.7. So if you like to answer those questions, don't use telemetry. If don't, just apply telemetry and let those people just to look into traces and determine by themselves. Because on traces, they will see that this system responds this time, this time, this time, this time, and this system return a long response without involving several teams to solve this issue. And also, what is more interesting, traces allow us to discover problems which are impossible to discover using method statistics. So if you rely on method statistics, you will know that operation A has a 15 percentile, X 90 percentile, Y. Operation B similar. And somebody asks you, okay, yesterday we had a period of time when all the operation took longer. You look into your code and you reply to them, but I don't see anything suspicious. 50 percentile is 1 millisecond longer than usual, but nothing apart from that. So why it took longer? Let us look at the example. That is a real example from our system. And it is how it happens. We have several operations, and CIS is one of these operations. CIS operation performs pretty well. So if there is one invocation close to 200 milliseconds, but apart from that, it is 70, 60, 80 milliseconds. It looks okay. The problem is that it was called 6 times. And those 6 times in total led to long response time. Why it was called 6 times? That's another question. But this tracing allows you to discover problems like that, problems which are impossible to spot and resolve using method statistics only. Okay, so it was about tracing itself. Every tracing library will provide you this functionality. So why we are talking about OpenTelemetry? OpenTelemetry is one of the framework which provide tracing. And OpenTelemetry is aimed to be a single open source standard for telemetry. Telemetry includes 3 pillars, how it is called usually: traces, metrics, and logs. In this presentation, we'll talk about traces only. So OpenTelemetry is a project maintained by CNCF. CNCF is a Cloud Native Computing Foundation, and it is a well-known organization which has many cloud-related projects. And OpenTelemetry is the second in terms of speed of development project in CNCF. Guess what? The first is Kubernetes. So apart from Kubernetes, OpenTelemetry is the project which has the biggest momentum so far under CNCF. OpenTelemetry was created as a merge of 2 projects, 2 well-known standards, OpenCensus and OpenTracing. OpenCensus is an open source version of Google internal library for tracing. OpenTracing is open source version which was heavily led by Google work as well. And for users of OpenCensus and OpenTracing, there is available tools to transform to OpenTelemetry. So giving the ground that it stems from OpenCensus, which is an open source of Google, give us some confidence that the framework will work well in large scale. So what are the key killing features of OpenTelemetry. I have one example, and this is what I especially like about it. I use it every day. So I have services which are deployed on Kubernetes. And the deployment is shown on this upper boundary. We have service A, service B. Traces are exported to OpenTelemetry collector. It is a separate pod. And then they are exported to Elastic APM, and we are able to create dashboards and to review those traces from Elastic APM using Kibana. That will be covered by Daniel on the next presentation. But the development cycle, which includes deploying to Kubernetes, is time consuming. Instead of that, I'm launching those services locally. It is possible to launch them locally. And I set up the same Docker, which works as OpenTelemetry collector, and Jaeger in another Docker. And there is no code change. Apart from this Docker compose or OpenTelemetry collector, the difference between those two is only configuration file, YAM configuration file, which contains no more than 20 lines. So when I switch YAM configuration file, I can launch my services locally without any modifications and have benefit of looking into their performance using Jaeger, which presents spans. Very cool feature, and it shortens our development cycle significantly. Another feature of OpenTelemetry is instrumentation. We do not create our services and applications in space. We use other frameworks to complete our works. For instance, we can use a SQL Server as an Azure service. Here in this example, we have our service, which uses SQL Server. But we didn't enrich SQL Server by a single line of code. Instead, in our code, we just include instructions, which was telling OpenTelemetry to instrument SQL Server invocation. It was 2 lines of code. And after that, you can see on the red line on the bottom that there are some icons denoting database. It is invocation to a SQL Server, and it is done automatically by the instrumentation code provided by OpenTelemetry. There are instrumentations for REST, there are instrumentation for gRPC, for different frameworks. Because there are many frameworks, you can start wondering whether my framework is covered by OpenTelemetry. To discover that, you have a QR code, which leads you to the registry page. The page is provided by OpenTelemetry. And you can see that there is no list of supported frameworks. Instead, there is a search box, because the list would be too long. So if you like to start using OpenTelemetry and is hesitating whether your framework is covered by it, just please look into this page, put your framework here, and see what languages are supported, whether it is supported at all, what languages are supported, what is the stage of development. And that concludes this presentation. Do you have any questions? I would be happy to answer.
Thank you, Piotr. So actually at the moment we don't have any questions in the chat, but let's give a minute because I see someone is typing. Okay, so we have the first question. Hi, I am using APM and I'm interested if I can define some KPI and triggers alarms based on them.
APM, I assume that the question is for Elastic APM. or not. If it is for Elastic, of course, Kibana, okay, it is Elastic. Of course, Kibana provides a method to create alarms based on KPM from Elastic. Am I correct, Daniel? Rather question to you.
Yep. Elastic does allow you to create watchers and alerts based on your data.
Yes, answer is yes. Can you recommend any guide? So for OpenTelemetry itself, OpenTelemetry.io is a starting web page which contains lots of examples, some Hello World starting tutorials in many languages. So I would recommend starting from that, going to OpenTelemetry.io, click on Get Started, pick your favorite language and complete 15 minutes tutorial, which will show you the basic capabilities of OpenTelemetry in your language. What is the cost? Sorry, Vladimir, you are expected to read the questions.
Yeah, not a problem. So what is the cost of implementing open tracing solution?
So what is the cost? So for our project, okay, for the whole suite, of course, if you have chain of requests, the OpenTelemetry trace will be presented only if the whole chain will export traces. If the chain will be broken in one point, those traces won't be presented together. So in your suite, every project should export to OpenTelemetry. For a single project, exporting to OpenTelemetry, let me think. We are just pioneering in Motorola Command Central, and the first version took us, I think, 2 days, 2 to 3 days. But the second, which we're using our experience, implemented in 1 day, while they spent half of a day solving problem which stem from bad configuration. So they miss the port. So few days. I would say that few days is a good estimate.
And here is the second part of this question. So how could you convince your managers to approve such a change, especially on production environment?
I think that maintenance cost is a main selling point here. So if you don't have OpenTelemetry, you need to scrap logs manually. And if logs have no common style, are not in the services are not in the common language, it takes more and more time. So the bigger deployment you have, the more time you spare by introducing OpenTelemetry versus grabbing in logs.
Okay, thanks. And the next one question is related to data storage. So each trace is very expensive if we talk about computing resources, and also if we're talking about data storage to store all the data related to traces. So do you have any suggestions on how to improve this, how to overcome these difficulties?
Okay, so in terms of processing traces, the library OpenTracing is developed having this in mind. So it is as high performance, low overhead library. For storage, you are right. If you export lots of traces and you use OpenTelemetry as profiler for your application, you can overload your storage, which will result in high bill or lack of space in your storage. However, if you have OpenTelemetry collector, as we have in our deployment, the configuration can contain filters. And you can filter traces which are exported to final storage using different criteria. So this is how you can limit, for instance, if you are developing a new product, you would like to have more visibility. So you allow more traces to be exported to the final storage. If it becomes mature, you can add filter just to limit number of data use for storage. So filtering.
Okay, thank you very much, Piotr. So I
Thank you.
think that's all questions for now. So we can move on to the next presentation. So let me introduce the next presenter. So welcome Daniel Falou. He is Senior Engineering Manager for Cloud Infrastructure Engineering's Observability platform, which is developed in Motorola. And before this role, he was working as a technical lead for Motorola's on-cloud products and has a great experience in cloud implementations. And today, Daniel will describe how CIE platform has implemented observability for infrastructure in the cloud. So, Daniel, it's your turn.
Great, thank you. Hello, good evening, everybody. So my name is Daniel Falou. I'm the Senior Engineering Manager for the CIE Observability team. And today we're just going to go over the architecture of how we achieve observability in CIE and some of the products that we offer. So to kick it off, what is CIE? CIE stands for Cloud Infrastructure Engineering. Basically, we provide a platform for our partner teams at Motorola to build their customer-facing products. So you can consider it just a platform as a service internal to Motorola. So you can see why observability would be important to offer to teams so they can have that in their products. So what's it built on? We are using Azure as our cloud service provider, and we roll our own version of Kubernetes inside Azure, which we allow partner teams to deploy to. So as part of observability, some of our offerings that we're going to go over are application logging, metrics, application performance and telemetry, which I just got a nice presentation on, and then monitoring logs and metrics on how you can work on them. So starting off, just a little bit more about a CIE. So we actually managed 17 different environments built in Azure and Kubernetes. We're hoping to have double that by the end of the year. So once again, you can imagine how important observability is to be able to see what's going on in those clusters from sort of a high level and alert on issues that happen when you're managing so many environments. You can't always be inside looking at it. Starting off with application logging. So how do we do application loggings? First of all, if you're running inside Kubernetes, everything we do is built off of Elasticsearch. We use the Elk stack. So of course, if you're running inside Kubernetes, we have a FileBeat daemon set running on every single node in there that just captures all of the standard output from your application, and we send that straight into Elasticsearch. We do have partner teams that are running outside Kubernetes, which means we're running an on-prem system, they're running devices in the field, they could be running their own VM in Azure. So we still want them to be able to see their application logs and create their alerts and metrics inside our environment. So for that, we provide a REST API for them to send their logs to. This REST API actually has a couple different formats you could send your logs as. The first one being the Elastic Commons schema, which is what we recommend everybody logs to, but we can't really control exactly how everybody's application schema is for logging. So we just provide it as a recommendation. We also provide endpoints for SOC logs. So if you have security monitoring, there's a specific format for that that we send to our NOC so they can monitor for security events. We have just specific messages. There's lots of different ways you can do logging. Besides the REST API, we also offer an event hub in Azure. So this is, you can think of an event hub as just a queue. It also has a REST API around it that you could send your logs to. And then those get pulled down into Elasticsearch via Logstash. So for your Azure resources, these are your Cosmos DBs, Service Bus, anything in Azure basically that you want to monitor. We have another Event Hub, and Azure has a very nice setting where you can stream your diagnostic settings to an Event Hub. So people can configure that. And then we have another Logstash that pulls that down inside the environment. So where can you see all these things? Obviously, we're using Elasticsearch, so Kibana is the UI. So the pros and cons of this. So we actually have an Elasticsearch and Kibana per environment. So there's 17 different ones. So the pros of this is compliance is easily achieved because we have data sovereign to the region that it was generated in. It's easy to get GDPR and CGIS compliance when your data is not leaving a region. But the cons of this is there's no single pane of glass for all your deployments. So you're going to have to go to 17 different Kibanas to see what's going on in that specific environment. So that's where your monitoring and alerting comes into play, which we'll get to here. So what does this application logging architecture look like? Basically, as we talked about, if you have an on-prem system, you could get inside Kubernetes using our logging API or the Azure Event Hub. The Event Hub also can stream your Azure resource diagnostic settings, and they come in via Logstash straight into Elasticsearch. FileBeat, again, a daemon set running on every node. All those logs get into Elasticsearch. Kibana for the UI. We have something called a SaaS token generator. This is what we use to secure our Event Hub and other resources. So a SaaS token is basically a security token that teams generate during their deployments. They can store it in an Azure Key Vault, and then that gives them access to our Event Hub. All right, so moving on to application metrics. So how do we do metrics? Once again, Elasticsearch. So we use MetricBeat. MetricBeat also runs as a daemon set on every single node. So this gets you lots of different modules that you can install to pull in different kinds of metrics. So the first one, Kubernetes metrics. We have kube state metrics running as a separate deployment inside the cluster. So you get lots of metrics from there. You get your pod, container, CPU, memory requests, all that stuff. We also pull metrics straight from each Kubernetes node. Kubernetes has a nice API that's available, and MetricBeat has a collector that just scrapes those. Prometheus, so we run the Prometheus module that pulls in custom metrics. These are teams build straight into their application, just whatever they think is relevant. Prometheus has a nice format, it's time series based, and they have a small footprint. There's also an Azure module, so you can get a couple things for free from Azure to get these metrics. You get like storage, VM. You could have access to the Azure Monitor API. But there's also lots that you will have to configure yourself, like Cosmos DB and other things. You will have to stream those diagnostic settings to our Event Hub to get those down. So that's why you see it in both of these columns, because some things MetricBeat gives you from Azure and some things you have to do yourself. We also support open metrics. And then we are running a StatsD server or a connector inside to MetricBeat. So if you're running that, you can just send it straight to us and everything ends up in Elasticsearch. So how do you gather metrics if you're not running inside our Kubernetes cluster? We actually have another Azure Event Hub with Kafka enabled. So MetricBeat has a Kafka output plugin. So teams are able to install MetricBeat on their on-prem devices or wherever they want, and then just configure that Kafka output, and it goes into MetricBeat. pulls into Logstash, and then ends up in our centralized Elasticsearch. And as I mentioned, as the resources, same thing, diagnostic settings to the Event Hub. So where are these? These are, again, the same, Kibana in every single environment. But now you'll see I've added Grafana here, which has a special use case for us. And I'll show you that in the architecture on the next slide. So we have on-prem metric beat going to our Event Hub, coming into Logstash, into Elasticsearch, a metric beat daemon set with all those different modules running, going into Elasticsearch. So Prometheus is kind of a new use case where we're pulling in. So we actually are going to be, or are running a Prometheus server in every single environment. And we have a centralized Grafana that, since Grafana lets you configure multiple data sources, we're able to get that single pane of glass for Prometheus metrics in every single environment. And the reason we did this is Prometheus metrics are by far the largest amount of metrics that we pull in. They account for about 25% of the entire load of our cluster. Prometheus metrics are usually smaller in size and time-based, but our teams generate a lot of them. So getting them out of Elasticsearch, which is expensive, to be honest, we are able to take the load off of Elasticsearch, but then also provide that single pane of glass for teams. Moving on to application performance and telemetry. Basically, you'll see it all on this slide. Elastic APM, since we're using Elasticsearch, that's what we use. So inside Kubernetes, we are running an Elasticsearch APM server. So if you have your application, you can just install your Elastic APM client and go straight to our Elastic APM server, and you're good to go. The nice thing about Elastic APM is, number one, they have lots of different clients, C#, Java, Node.js, pretty much any programming language you want to use. But you get a lot of that instrumentation for free. So your transactions, your spans, all of that stuff is auto-generated just by installing the Elastic APM client. So it's really light onboarding, and we recommend teams to do that. So if you're outside Kubernetes, you are also free to use Elastic APM. We actually have a public endpoint that's available for teams to just stream your Elastic APM to. Azure Function, once again, you could install the client on an Azure Function and send it straight to our server. For client applications, your Angular apps, front-end, client-facing things, you can use Elastic APM RUM. RUM is real user monitoring. So this is just a JavaScript library that you put on your page, configure a URL, and then you'll start getting that data. It's similar to Google Analytics, something like that. OpenTelemetry, as you just heard about. So there's an Elastic exporter for Elastic APM. So it kind of sits between Elastic APM server and your OpenTelemetry, just to make sure that those metrics get into the format that Elastic APM is going to understand and be able to send to Elasticsearch. In the newest version of Elasticsearch, Elastic APM actually natively supports OpenTelemetry. That feature is still experimental, though. So for now, the recommended way is to use the Elastic exporter in between. Open tracing, similar to OpenTelemetry, but there is a bridge in between. It's just a different way of converting it to data that Elasticsearch understands. And once again, these all live in their separate environments. So what does it look like? So inside Kubernetes, we have our APM server running, and then you configure your agent from wherever you are. You're in on-prem, you've got your APM agent sending to the public URL. You got your command line application, you use the RUM agent, OpenTelemetry exporter, everything goes to the APM server. So it's nice to have just a one-stop shop for all your application performance needs. So monitoring, how do we make sure we're getting alerted and not having to go visit all these 17 different environments? So the first thing we do, Elastic Watchers. These allow you to create queries that you can execute on a certain interval and then perform some action. So for us, we use Google Chat a lot, so you could get like low-level alerts in the Google Chat that you're monitoring. Otherwise, we use PagerDuty, and then you will get triggered, and somebody who's on call will be able to come in and diagnose the problem on the environment. Kibana alerts are kind of new to Elasticsearch. These are configured from the UI. They have a nice little way to view the thresholds that you're getting, and then you can create your alerts on those. So you can see like spikes in CPU and memory, stuff like that. So we also have a machine learning platform that connects to Elasticsearch. So this is used for basically for anomaly detection. So we're hoping to have people not have to come in and configure these metric threshold alerts, but instead in the background, we'll have machine learning jobs running that'll automatically alert based on what it's seeing. Another Elastic product we use is Heartbeat. So Heartbeat basically just pings a URL and checks for a response. So you could configure it to just look for a 200, you give it a URL, pings that. There's a nice UI in Kibana that you could create alerts for and see the health of your URLs. For API availability monitoring, we use Azure Functions. So you could go create a timer function, and this is for your like multi-step processes. So you have an API that accepts an input, and you want to do something with the output, and stuff like that. So the Azure function will run every 5 minutes. And then the nice thing about this is it can just stream its logs or the result of the test to our event hub that ends up in Elasticsearch. So for security monitoring, we have that special log type that we're monitoring, and we just ship those off to our SOC, just from what we see in the logs. So where are all these different things? Well, there's the Kibana per environment. So the way we make it easier for teams to deploy their watchers and alerts throughout these environments is we actually provide a wrapper API for the Elastic APIs. So this way teams can have their watchers and alerts in a Git repo, and then they simply run a pipeline job to deploy these to the various environments. So in theory, you don't actually have to go to any of these Kibanas. You could run all your monitoring alerts to be set up through a pipeline, and then you'll just get alerted when something is wrong. We also have a monitoring control center per environment. This is where you can go in and configure your machine learning and just see the different machine learning jobs and how they detect your anomalies. And then the centralized Grafana for Prometheus metrics. So what does this look like? So here we have Elastic Watchers, Kibana alerts, monitoring control center. They all feed into Elasticsearch. Heartbeat feeds into Elasticsearch. Azure Functions running, Event Hub coming from Logstash into Elasticsearch, and then the centralized Grafana for all my metrics. So on our last slide here, just give you some details on one of our 8 production environments. So we're running Elasticsearch. We currently have about 20 terabytes of application logs. This is a 30-day retention on application logs. We have about 360 different indices and close to 18 billion logs. It's one of the big things that we like to talk to teams about is make sure you're really putting thought into what you're logging, especially when we have these big environments with lots of teams sharing it, do you need to log everything? Do you need to be logging 1,000 to 10,000 logs a minute in your application? Or are you just logging for the sake of logging? That helps with costs. All these Elasticsearch instances, they run on pretty beefy VMs inside Azure. So if teams pay attention to their logging, it'll drive costs down, which makes everybody happy. For Azure logs, we have about 50 gigs of those. Kubernetes metrics, 2 terabytes. And then, as I mentioned, Prometheus metrics are huge. We've got lots of them. There's over 3,000 different custom metric fields. The teams generate 8 terabytes of data. So it'd be nice to have those centralized in a actual Prometheus server instead of Elasticsearch, since that little square gets expensive. Docker metrics, we have about 2 terabytes of those, and then Azure metrics, small. But yeah, so that is how we do observability in cloud infrastructure engineering. Does anybody have any questions?
Thank you, Daniel. So currently I don't see new questions in the chat. So maybe let's give a minute or two. So if anyone would like to ask questions regarding infrastructure monitoring, please feel free. Okay, so there is a question regarding data security. So what about RODO, or limit? It means GDPR, or limited access to the log files, which has some sensitive data.
Yes, that is a great question. So inside Elasticsearch, they have a concept of roles and role mappings. So when a team creates a project, we actually create a role and a role mapping for them that gives them access to only their specific index inside Elasticsearch. So even though we have 360 different indices, their role gives them only access to their index. And this is tied to an Azure Active Directory group, which has their whole team. And then if they want to get access to, say, a production environment, there's compliance that they have to attest to. So if you're in the United States and you want access to one of our production environments, you have to go through the CGIS certification. If you're in some of our other environments, basically, it's the same process. So whatever is local to the environment, like a UK environment or Australian, Canada environment, you have to go through the process before you are added to those Active Directory groups that will give you access to it.
Okay, thank you. And the next one is about how are you controlling the number of logs? So each development team can set up numerous types of logs to be sent to the system, and do you limit it somehow?
We do not limit it at the moment. It's something we've discussed. But basically what we do is we get alerted on a certain threshold. So we have access to the ingest pipeline, and we can see what's coming in. So if we see a team, I think right now it's about 500 a second, which is still a crazy amount of logs. But if we see that coming in, we'll get an alert, and then we have every team's contact information. So we will reach out to them and say, hey, what are you doing? Do you really need to be logging this much? In the future, maybe we can find a way to limit that, but right now we kind of don't want to stifle teams by putting a filter between them. We just reach out to them and make sure they're being good citizens in our environment.
Okay, thank you, Daniel. So I think we can move on to the next third presentation. So let me introduce Bartlomiej Tirpa. He is engineering manager at Motorola, and he is responsible for digital evidence management system, which is developed in Motorola in Krakow. He has great experience. So more than for 20 years, he is leading development and maintenance of different enterprise class products, so on-prem and cloud-based. And today he will describe how is organized monitoring in our DEMS system and what are the specifics. So Bartlomiej, please.
Thank you. Good afternoon, everybody. Just Bartek for short. Yeah. Okay, let me start. A story about our DEMS system, multi-cluster live system monitoring and telemetry. First of all, let's raise a question how a multi-cluster dispersed system with more than 800 customers, agencies available worldwide can be monitored 24/7 by a single Scrum team. This is, I think that might be pretty interesting for you because we are actually everywhere worldwide. So let's start from the agenda. First of all, I'll let you know what is a DEMS and provide you a couple of main services and fitness functions of the DEMS system. Then I'll show you the monitoring flow, then a couple of examples of ongoing tests, errors, and some telemetry, then pros and cons, and finally questions and answers session. Okay, so let's start from what's the DEMS. Yeah, that's an example of DEMS. Motorola is actually developed a couple of them. This is Command Central Vault. That's a digital evidence management system. And this, as I said, an example of them, where you can see some assets, some files, and the thumbnails available on a GUI. This is an example of GUI, where you can see some functions like a search in a top right corner, and you can also search via group types on the left side. So those are kind of general features available here. So let's go to the next slide. So as I said, that is digital evidence management system, and the key services are to store digital evidence, the digital evidence like screens, like video files, pictures, recordings, recordings of sensitive data from the public safety agencies. So you can manage them. Yeah, you can manage them by adding annotations, tags, searching, filtering, purging on time when necessary. You have to purge an asset. You cannot keep it forever. Downloading, uploading, gathering audit logs. And you can share between many parties. First of all, between police departments, agencies, between courts, attorneys, prosecutors. Okay, where are we? First of all, we are on AWS in 5 regions. In the USA, in the UK, Canada, Germany, and Australia. So those 5 systems are independent, however, still managed by the single Scrum team of developers in terms of issues on production. Okay, let me go to the next slide. So let's go to the DEMS monitoring aspects. So as I said, we are on AWS. Yeah. However, we are using we have connection to the Microsoft Azure, where we where we use our testing 24/7 health checks. The health checks are built on that are Cucumber tests run on a Selenium, but the pipelines are built on Azure in a Docker image. And we use Datadog to use a telemetry and alerts triggering. So the Datadog is gathering information from the tests and directly from the DEMS system ported on AWS, and sends information about issues to the Hangouts chat, which is being monitored by the PagerDuty engineer on shift, and of course to PagerDuty if that is an outage. Let me give you some example of anomalies which we are monitoring. This is our definition of a kind of super test. What are we checking? What is important from the end user perspective? The end user who uses the CC Vault application. So first of all, of course, this is upload. Yeah. The big upload tests checks the following things. This is login. This is token. Upload init. Upload to S3 bucket in AWS. Completion of upload and generation of thumbnails in a defined timeframes. Those are the main kind of fitness functions defined in our product. So once a threshold is overcome, something wrong happens, we are getting this kind of errors. So this is another example. This is actually an example of a message from Datadog sent to Google Chat, a real example. So let's focus on the text which is in red. So those are the main informations, like where is it? We know that is in production UK cluster. What happened? The device upload test failed. What exactly? Indexing, antivirus, and thumbnails. There are more informations, as you can see here, like exact information about the file, what happened, not scanned without thumbnails, device ID, etc. Yeah, those informations are important for the engineer who is on PagerDuty shift and starting troubleshooting. So we are getting those information immediately. What key metrics are we monitoring? So first of all, request processing metrics, then user perspective, infrastructure, database, and of course reindexing. So let me give you a couple of them. Of course, there are much more. Those are from Datadog. So you can see that from the request processing metrics, we are monitoring, for example, requests to applications, so RPS, average request duration by endpoint. Yeah, distribution of response codes, where we can see how many 200s are being processed in comparison to the 400s. Yeah, so successful, not successful. Very important metrics on daily basis to monitor the system and troubleshoot if something wrong happens. There are more, of course, not only those four. This is just an example. So user perspective performance, very important metrics, especially that gives developers a view of the situation in a real system. It gives the opportunity for the people who are coding to see the behavior of that system. Yeah, that is very important. So logging page, load time. This is from 1 hour. You can see there was a peak, so the logging page was somehow affected. So we were able to check what was going on, to check if something wrong happens, or that was just a small peak, which we could have ignored. So you can see the trend in a file upload. There was a 3 peaks in between those 3 days. Yeah, so we were able to find it and see what's going on there. If something wrong is happening on the system. Okay, and infrastructure. So CPU for IAMS, Adobe Experience Manager, which we are using in a command center mode application, Mongo CPU usage, MML, FSV. Those 2 are our internal services. Database, Mongo database, plenty of them. Those 4 are just examples. So if we see some anomalies here, we can immediately react, even if PagerDuty or chat threshold was not, and information on the chat wasn't sent, so we can see that. And reindexing, very important from our perspective, because we have in the past some issues here. So we defined actually max reindex count possible and issue occurred level thresholds, so we can monitor it and see if reindexing is going well or something wrong is happening, and react immediately by paging some other teams like infrastructure teams, yeah, to help us to restart some services, etc. What are the main pros and cons of those solutions? Especially saying about the combination of AWS and Azure testing. Well, we are dependent on 2 platforms. So if Azure fail, we are blind. Yeah, we cannot see our monitoring. It happened once at least, but we can always go to the system directly in such situation and do manual test and check if we can log on there, if everything works. What are pros? Well, for sure, developers can see the user perspective. This is for telemetry. Yeah, for so quick overlook of the telemetry often accelerate troubleshooting. I think Daniel may say something about that, and Piotr too. But in case of an outage, we can quickly go to our telemetry and see where is the problem. We have pretty good scalability, and adding new tests are pretty easy to the Azure testing. So that works well. So that's it. Thank you very much for your time. So if you have any questions.
Thank you, Bartek. So I see one person is writing the question. So let's give maybe a couple of minutes. Okay, so that's a general question regarding that if we share the slides after the meeting. So thank you for saying that very interesting topics. I'm not sure if we will share slide decks which have been presented today, but we will for sure publish this video recording, because our session today is recorded, so you may come back to it at any time and look at this information once again. So it will be shared on our Motorola site, so you will be able to do this. Also, from time to time, we are performing some advertisement on Facebook and LinkedIn, and it will have links to our platform where you can see all the recordings from these and older meetups which have taken place. Okay, so I see that there are no questions. So in this case, I think we can thanks everyone, and maybe we will be closing our meetup for today. So once again, thank you very much, Piotr, Daniel, Bartek, for making great presentations today, and thanks everyone for joining our meetup today. See you next time.
Thank you.
Thank you.
Thank you. Bye.